So here's today. It says 4.5, and I'm already somewhat past that. So again, we'll probably formally finish early today because I'm ahead. Frankly, even if I quote unquote catch up or even fall behind, I got some buffer days coming up. Okay, so again, our formal class today will be in fairly early, I think. Then I'll let you ask questions, and if you don't have any questions, then we'll stop and we'll be done. Okay, tomorrow I was going to give you a lot of time, hopefully, on the quiz. Hopefully half the class period or maybe even more, so you can work on it because it's a little bit tougher. I will give you a graph. You have to try to come up with the equation of the graph, either a cosine or a sine. Okay, so the closest thing to it would be, oh, what problems that we do were sort of like that. Yeah, maybe something like 4.5, page 229. So the closest thing to it might be one of these guys here. Okay, so I'll give you a graph. So you have to analyze what's the amplitude, what's the period, what's the shift, right? Shift so much horizontally and vertically, and come up with either a cosine or a sine graph. Okay, so it's definitely a little bit tougher. So I'll try to give you at least half the period, but you already know, even if I don't give you the whole period or 10 minutes, you still have the whole weekend to work on it, right? Okay. So that's what's going to happen. All right, so I left off here. Okay, so we were done with 4.5. I was getting started with 4.6. Okay, so I had already done 1 through 6. So I'll do some more problems from 4.6, and then I'll be done with today. I wasn't going to finish 4.6 necessarily. We have plenty of time, and we still have, what, 2 more weeks before the next exam, which is November the 6th. So we're over here, right? So we still have a couple of weeks left. So we have plenty of time, I think. All right. Okay, so I already knocked off 1 through 6. So let's go on to the 7 to 35 type of problems. Okay, so remember 1 through 6 yesterday. It was just what quadrant are we in, right? So we had to say, okay, are we in the first quadrant, second quadrant, third quadrant, fourth quadrant? I already did 2, 4, and 6 because you don't have those answers in the back of the book. And you can do 1, 3, and 5 on your own, right? Okay, then I think I did one of these problems. A super big chart. Okay, and again, it looks scary, but my advice is you can make it less scary if you only worry about sine and cosine. Just get the x and y coordinates, because then all of these are just going to be related to that, right? Tangent is just sine divided by cosine, and then these are just the reciprocals, right? Okay, so I did one of those. I'll do a couple more from this chart for you now. Okay. Okay, so yesterday I did 7 pi over 6. How about I'll also do 5 pi over 4, which is also somewhere on that chart. 5 pi over 4 is, I guess, is the next one. So the big question is, where is 5 pi over 4? Well, you should know pi over 4 is here, 45 degrees. Now, you could do the conversion like I did over here, figure out the degrees, because you're probably a lot more comfortable with degrees. But even if you left it in radians, if you already know this is pi over 4, then just count 5 pi over 4s, right? Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, right, which is pi, 5 pi over 4. So I'm in the third quadrant. Okay. You know the reference angle is pi over 4 or 45 degrees. So that means x and y are both radical 2 over 2, except for the sign SIGN. I'm in quadrant 3, so they're both negative. Okay. So the corresponding point on the unit circle for an angle of 5 pi over 4 would be negative radical 2 over 2, negative radical 2 over 2. Okay, so this is 45 degrees times 5, which is what, 225 degrees? In degrees, 45, 90, 135, 180, 225, right? So 225 degrees. In radians, pi over 4, 2 pi over 4, which is the same as pi over 2, 3 pi over 4, 4 pi over 4, which is the same as pi, 5 pi over 4. That's where we are. And just for fun, if you want to keep going, 6 pi over 4, 3 pi over 2, 7 pi over 4, 8 pi over 4, which is 2 pi. All right, so the cosine of an angle, give me the x-coordinate. Sine of an angle, give me the y-coordinate. Well, in this case, they're both the same, negative radical 2 over 2. So cosine of 5 pi over 4 is negative radical 2 over 2. Sine of pi over 4 is also negative radical 2 over 2. And see, that's what I mean by once you have those two, right, then you can fill out the rest just with properties of reciprocals and fractions and so on. Okay, so tangent is the ratio of the two, sine divided by cosine. But you already know that if you have anything divided by the same thing, it's 1, right? It would formally, sine over cosine would be negative radical 2 over 2 divided by negative radical 2 over 2. It's hard to even say that, but that's the same number as that. So when you divide them, you get 1. So tangent of 5 pi over 4 is simply 1. Okay? And now you just have all the reciprocals. Okay? Secant is the reciprocal of the cosine. So I flip that, negative 2 over radical 2, which is the same as negative radical 2. Okay? And by the way, when you have this situation, you should simplify it to that. Okay? You know how to rationalize the denominator. Okay, so I'll remind you, negative 2 over radical 2. If you multiply top and bottom by radical 2, like that, this becomes regular 2, right? So this is regular 2, it'll cancel that 2. So all you have left is negative radical 2. Okay, so negative 2 over radical 2 is best written as negative radical 2. And cosecant, same thing. Cosecant of 5 pi over 4, negative radical 2. Because you flipped this, but we just did that calculation there. And reciprocal of tangent is cotangent. So what's the reciprocal of 1? Well, it's still 1. So cotangent of 5 pi over 4 is still 1. Is that right? Okay, so that's pretty much about that. Okay, and next one I'll show you is 3 pi over 2. And 3 pi over 2 was in the chart somewhere. Where's 3 pi over 2? Yeah, this one is 3 pi over 2. By the way, 2 pi should be easy because 2 pi lands in the same spot as 0, right? Okay, so 3 pi over 2. Where is 3 pi over 2? That's 270 degrees, right? That's the South Pole, as it were. Okay, so you should already be familiar with 90 degrees being pi over 2. So pi over 2, 2 pi over 2, pi, 3 pi over 2, 4 pi over 2, 2 pi. Okay, so what is this point? The order pair is 0, negative 1. Right, so cosine, give me the x-coordinate. Sine, give me the y-coordinate. So remember, it goes cosine theta, sine theta is x comma y. If you want to put it in your cheat sheet, you may. If we were meeting face-to-face, I'd make you guys memorize it, but my memory trick would be it's alphabetical order, as I said, right? X is before y, cosine is before sine in the alphabet. So, right, so therefore, what is the cosine of 3 pi over 2? What is the x-coordinate? 0. What is the sine of 3 pi over 2? Give me the y-coordinate, negative 1. So cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. And then after that, so that's what I mean by you really shouldn't get too scared about all these others. If you just focus on the top part, sine and cosine, right? Once you get to sine and cosine, then all these bottom ones follow by taking fractions and reciprocals and so on. Okay. All right, so tangent, 3 pi over 2, it's sine divided by cosine. So it's negative 1 divided by 0. Well, you can't divide by 0. So tangent of 3 pi over 2 is undefined. You cannot take the tangent of 3 pi over 2. Which incidentally also means on the graph, you would end up having an asymptote. Okay, so later on, we'll see the graph of the tangent function. There's an asymptote at 3 pi over 2. Okay, then in reciprocals, secant is the reciprocal of the cosine. So what's the reciprocal of 0? 1 over 0 is not defined. So secant of 3 pi over 2 is also undefined. So on the graph of secant at 3 pi over 2, you would also have an asymptote. Cosecant of 3 pi over 2 is the reciprocal of -1. 1 over -1 is -1. That's okay. Cotangent of 3 pi over 2 actually is defined. You might say, well, how do you take 1 divided by undefined? Well, you don't think of it that way. Although in some sense, if you have 1 over undefined, that's sort of like 0. Remember, cotangent can be defined as cosine over sine, right? So 0 divided by -1 is 0. Okay, and that happens a lot. Okay, if you get one trig function which is undefined, the reciprocal is 0. And likewise, if you already have a trig function that come out to be 0, right, then the reciprocal is undefined because you can't do 1 over 0. Okay, so even though the tangent is undefined, the cotangent is defined, and that comes out to be 0. Okay. Okay, then the only other one I wanted to show you was 5 pi over 3. It's in the chart. I want to show you one from each quadrant. Well, first quadrant is too easy, so I didn't do a first quadrant one for you. I did a second quadrant. I did a third quadrant. I did a quadrantal angle. That means one that's right on the X or Y axis. And I'll do a fourth quadrant angle now, which is 5 pi over 3. Okay, so first I have to figure out where is 5 pi over 3. There's several ways to approach it. You know that if you have just pi over 3 is 60 degrees. So then I just count 5 of those. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. That's over here. And if you keep going, 6 pi over 3, which is 2 pi. So where's 5 pi over 3? I go around a whole circle and I back up, looks like 60 degrees. So that'll be 300 degrees. Okay, so here's 5 pi over 3, quadrant 4. Quadrant 4, x is positive, y is negative. Okay, it's a multiple of 30 degrees. So that means one of the coordinates is going to be plus or minus a half. Okay, so I always go something like this. Again, it doesn't have to be that accurate, it's just 60 degrees. So I just go like that, and I go like that, okay, to compare x and y. So does it look like the x or the y is halfway across the circle? Okay, if you look at the y, okay, looks like it's definitely more than halfway. But if we look at x, okay, that seems about halfway across the circle. That means x is a half. So y is automatically the other number, quote unquote. The other number is radical 3 over 2. It's about 0.866. So that seems like it's about 85% of the way across the circle. This one's about half. So 1/2 comma negative radical 3 over 2. Okay? Again, I'm in quadrant 4. So quadrant 4 means x is positive, y is negative. And there we go. So cosine of 5 pi over 3, give me the x coordinate, 1/2. Sine of 5 pi over 3, give me the y coordinate, negative radical 3 over 2. Again, for the rest of the chart, you just do your ratios and reciprocals. So tangent 5 pi over 3 is sine divided by cosine. So negative radical 3 over 2 divided by 1/2. Okay, and I'm not sure if I told you guys this trick before, but if you ever have a weird looking fraction like this, but you're dividing the top and the bottom by the same thing, 2, you can just lose the 2's. So see how it's negative radical 3 over 2 divided by half? Just ignore the 2's. And you have negative radical 3 divided by 1, which is negative radical 3. Okay, so again, if you ever divide the top and the bottom by the same thing, you can just lose it. So you can just lose the 2's. Okay, so maybe just a little timeout here. If you have A over B divided by C over B, you can just lose the B's. And you have A over C. You can cancel out the B's. Okay, the justification, well, you can multiply top and bottom by B, and then they're all gone, right? So if you went like this, multiplied by b, then it's gone, 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 gone. All the b's are gone, so you have a over c. Okay, so likewise over here, you can multiply top and bottom by 2, so all the 2's are gone. 2 would cancel that 2, the other 2 would cancel that 2. So you have negative radical 3 over 1. Now, don't do that trick of this number and this number are not the same. So like if this is a 2 and this is a 3, then don't do that trick. Okay, but if they're the same number, that's a 2, that's a 2, just lose them, and you have negative radical 3. Okay, and then the reciprocals. So secant is the reciprocal of the cosine. So secant 5 pi over 3, reciprocal of 1/2 is 2. Cosecant is the reciprocal of the sine. Remember, one function has a cosecant, the other does not, sine. So I flip this, negative 2 over radical 3. In this particular case, I'll let you leave it like that. But if you rationalize the denominator, I'll always accept it. And then the reciprocal of the tangent is a cotangent. So I flip negative radical 3 over 1, which is negative 1 over radical 3. Okay, so that's that. All right, so now find the values of all the trig functions from the given information. So I'll do some problems from 9 to 15, and then that was going to be done, folks. That's pretty much about it. I'll do graphs. I'll start the graphs tomorrow, but I still have all of next week to get started on that too. So if they just give you stuff like this, how do you figure out everything else? All right. So that's what I'm going to tackle now. Okay, so number 9, cosine of t is 3/5. I'm in quadrant 1. All right, now you can't get any better than quadrant 1 because everything is positive in quadrant 1. All 6 trig functions are positive in quadrant 1, right? Okay. Second, third, and fourth quadrants, only one of the 3, sine, cosine, and tangent, right? Only one of them is going to be positive. And remember the acronym, all students take calculus, you know, this funny thing, all students take calculus. That'll help remember, right? So quadrant 1, they're all positive. Second quadrant, only the sine. Third quadrant, only the tangent. Fourth quadrant, only the cosine are positive. Okay. So what about secant, cosecant, and cotangent? Well, if a number is positive, the reciprocal is positive. And if a number is negative, the reciprocal is negative, right? So if you get secant, cosecant, cotangent, the sign SIGN will be the same as its flip, as the reciprocal. All right, they give me the cosine of t. Now, I will use the trig identity. Cosine squared t plus sine squared t is equal to 1. You probably remember that was a biggie from trig. Okay, again, if you want to put it on your cheat sheet, you may, but this is something you really should memorize, or you ought to memorize. And again, if we were meeting face to face, I would make you guys memorize this. So anyway, so in other words, once you have cosine, you can figure out the sine always by means of this, right? So once you have either cosine or sine, plug in here to find the other trig function. All right, so cosine squared t plus sine squared t is equal to 1. All right, now I'm going to plug in 3/5. So put 3/5 over here. 3/5 squared plus sine squared t is equal to 1. 3/5 squared is 9 over 25. So 9 over 25 plus sine squared of t is equal to 1. Subtract 9 over 25. So that arrow means I'm subtracting 9 over 25. So 1 minus 9 over 25. Well, 1 is like 25 over 25, right? So 25 over 25 minus 9 over 25 is 16 over 25. So 16 over 25 equals sine squared of t. Do the square root. That's a 16. Ordinarily, you would have to say plus or minus. That's where they tell me I'm in quadrant 1. So if I'm in quadrant 1, everything's positive. So sine of t is 4/5. All right, so I have cosine t is 3/5, sine of t is 4/5. Now I can do the rest. The rest of the problem is like this, right? Okay. Once I have the sine of the angle, the cosine of the angle, then, you know, all this stuff, just do your reciprocals and ratios and so on. So I have cosine of t is 3/5, sine of t is 4/5. So tangent is sine over cosine. So 4/5 divided by 3/5. And there's that trick again. I'm dividing both the top and the bottom by 5, so just ignore the 5's, 4 over 3. And then the reciprocals are very easy, right? Just know what's the reciprocal of what. Reciprocal of cosine. I said co, so reciprocal does not have a cosecant. So flip it, 5/3. Cosecant, there's a co, so the reciprocal doesn't have a cosine. So sine of t was 4/5, cosecant of t is 5/4. And most people don't have any trouble with tangent, cotangent, right? So cotangent is the flip of the tangent, 4 over 3, 3 over 4. Okay, so that's that. All right, and something else I want to emphasize, I let it go on the previous quiz, but I may not be as generous on future quizzes or especially exams. I think I mentioned before, I tend to be much more lenient on quizzes than exams. Okay, you're not supposed to just put cosine equals, sine equals. It has to be cosine of theta or cosine of t or cosine x. Okay, so you should not write just cos equals 3/5, like some of you did in the last quiz, or sine equals 4/5, or cotangent equals 3/4. Has to be cotangent of t or theta or x or something like that. Okay. All right, 13's a little bit tougher. Tangent of t is equal to 2. T is between 0 and pi over 2. Well, this should still be nice because where are we if we're between 0 and pi over 2? What quadrant? Well, that's between 0 and 90 degrees, so we're still in quadrant 1. So quadrant 1, you can't get any better, right? Quadrant 1, everything's positive. So keep that in mind. All right, there's a couple of other identities that you had from trig. I write them again here, and again, you can put these on your cheat sheet if you wish. 1 plus tangent squared of t is equal to secant squared of t. Remember anything like that from trig? And 1 plus cotangent squared of t equals cosecant squared of t. Okay. In other words, once I have the tangent, I can find the secant. Secant is the reciprocal of the cosine. So once I get that going, I can get the ball rolling and find everything else. Okay. So tangent of t is 2. I'm in quadrant 1. So how do you know that? T is between 0 and pi over 2, 0 and 90 degrees. So it's first quadrant. Everything's positive. Okay, so 1 plus tangent squared t equals secant squared t. So 1 plus tangent was given to be 2. So 2 squared equals secant squared of t. 1 plus 4 is 5. So 5 equals secant squared of t. Take the square root. So secant of t is radical 5. Therefore, the reciprocal, cosine, is 1 over radical 5. Okay, so I found the cosine of t, right? So secant is the reciprocal of the cosine. So I flip radical 5 over 1, 1 over radical 5. By the way, cotangent easy. If the tangent of t was 2, 2 over 1, the reciprocal is 1 over 2, 1/2. All right, so I got the tangent, cotangent, secant, cosecant, and now that I have the cosine, I can find the sine easily by plugging back in here, right? So cosine of t is 1 over radical 5. I know sine squared of t plus cosine squared of t is equal to 1. Okay, again, you can go ahead and put these formulas on your cheat sheet. And I'm even going to let you put, this one that you should memorize. But anyway, cosine squared of t plus sine squared of t is equal to 1. All right, so sine squared of t plus cosine was 1 over radical 5. So cosine squared is 1 over radical 5 squared equals 1. Okay, so what is 1 over radical 5 squared? Well, 1 squared is 1. Radical 5 squared is 5. So I have sine squared of t plus 1/5 is equal to 1. Subtract 1/5. What's 1 minus 1/5? 4/5. Think of 1 as 5 over 5, right? 5 over 5 minus 1 over 5, 4 over 5. And square root both sides. So I'm in quadrant 1, so I want the positive. So sine of t is square root of 4/5. I can't do anything with the square root of 5, but the square root of 4, you should change to 2. So 2 over radical 5, and therefore the cosecant, the reciprocal of the sine, cosecant of t, flip it, radical 5 over 2. All right, so that's the process for doing something like 13. Use your identities to figure out what you need. Okay? So usually you want to have at least sine or cosine. Once you have either sine or cosine, you can always plug it into here. If they give us tangent or cotangent, then you want to use these guys. Use either this one or this one to help you with the others. Okay. All right, folks, then I was going to show you, let's see, 15, and then I was going to be done. So I'm actually already finished after this one. So I'll be done in a few minutes, and then I'll let you ask questions. And if you don't have any questions, we're done for the day, folks. Okay, secant of t equals 3. T is in quadrant 4. Okay, so here's our first instance where we don't have the quadrant that we quote unquote like. We're in the fourth quadrant. Okay, let's think about the fourth quadrant. If I'm in the fourth quadrant, x is positive and y is negative, right? So secant of t is 3. T is in quadrant 4. So quadrant 4. So first thing I'm going to do is get the reciprocal, obviously. I mean, once they give me one piece of information, you can always find the reciprocal. Reciprocal of the secant is the cosine. Secant doesn't have a co, so reciprocal is co. Cosine is 1/3. Okay, I'm in quadrant 4. So again, if I do my all students take calculus, cosine is positive, so the sign will be negative. S-I-N-E is negative. The sign of the sine, the S-I-G-N of the S-I-N-E will be negative because I'm in quadrant 4. Okay, so cosine squared t plus sine squared t is equal to 1. So plug in 1/3, right? Cosine was 1/3. So 1/3 squared plus sine squared of t is equal to 1. 1/3 squared, 1/3 times 1/3 is 1/9. 1/9 plus sine squared of t is equal to 1. Subtract 1/9. 1 minus 1/9 is 8/9. Think of 1 as 9 over 9. 9 over 9 minus 1 over 9, 8 over 9. Square root. Normally you would put plus or minus. In this case, though, quadrant 4 means I keep the negative. And that's kind of unusual. Many times, especially in word problems, when you have a plus or minus, we throw out the negative. But in this case, we have to keep the negative. We throw out the positive because they told me I'm in quadrant 4. Okay, so sine of t is a negative. Square root of 9 is 3. Square root of 8, well, square root of 8 is the square root of 4 times 2, right? And the 4 will come inside and become a 2. So sine of t is negative 2 radical 2 over 3. And therefore I flip it. If I flip it, I get the reciprocal cosecant of t is negative 3 over 2 radical 2. All right, and then tangent, cotangent. So tangent was sine over cosine. So let's see, negative 2 radical 2 over 3. So sine, negative 2 radical 2 over 3, divided by the cosine, which was 1/3. So divided by 1/3. Okay, this is a similar theme. This theme happens a lot when we're doing these kind of problems. That 3 cancels that 3. Again, if you divide the top and the bottom by the same number, right, there's a divided by 3 in the numerator. There's a divided by 3 in the denominator. You can just cross them out. So I have negative 2 radical 2 divided by 1. Well, if you divide by 1, you don't have to write it. So negative 2 radical 2. And then the cotangent of t, I just reciprocate tangent of t. So if I flip this, I just get negative 1 over 2 radical 2. And that's about it. Okay. All right, so that's as much as I was going to do today. After this, we will have graphs. But for tomorrow, I'll start the graphs. Actually, I wasn't going to do a whole lot of problems tomorrow involving graphs, but just get you started with that. See where we're headed with more graphs like these, except there are different functions like tangent and secant. So I have to show you how that works. So I probably won't get to this until Monday. Tomorrow I'll just introduce the graph of the tangent, cotangent, secant, and cosecant. Okay, but for now I'll stop and check the chat and see what we might have. Okay, so let's see. So 5 pi over 3, how do I get the cosine of 5 pi over 3? Okay, and actually for problem number 11, I'm assuming from the same section. Okay. Okay, I think I'm going to do it. Of course, if I do it, it ends up I'm doing all the problems, but that's okay. I don't think I mind that much, and I'm sure you don't mind either. So I'm assuming you're asking for problem 11 in the same section since I don't see a section, so I'll go ahead with that. Okay. So, oops.
Yeah, I believe it was for one of the examples that you did earlier, where the cosine was somewhere halfway, and you designated it as 1/2. So I wasn't sure exactly how you came to that.
Yeah. Okay. I'll go back over that. Okay. So let me share the screen again. If you still want to put something in the chat, you may. Again, I'm noticing I can't see the chat while sharing the screen, so I have to switch back and forth behind between those, I guess. Okay, so 5 pi over 3. Let me start from scratch. You can see I'm just freehanding. My circles aren't great, but they don't have to be that great. So where is 5 pi over 3? Okay, so you can start at 5 pi over 3, which I know is 60 degrees. And then you just keep going on from that. So 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 2 pi. So it's just like if you take a pie or cake and chop it up into 6 pieces, right? 1, 2, 3, 4, 5, 6 pieces. Okay, I'm trying to figure out the coordinates here. So that means I go like that, and I go like that. And you can see my picture's not that accurate, but it doesn't have to be. Okay. When you have a multiple of 30 degrees, like this turns out to be 300 degrees, I believe it was. Okay. And again, if you're not sure about that, you can always go like this. Over pi. Pi's cancel out. 180 divided by 3 is 60. 5 times 60 is 300 degrees. Okay. So when you have a situation like this, that's true for this angle and this angle and this angle. One of the coordinates is always going to be plus or minus a half. Okay. It's always going to be plus or minus 1/2, plus or minus radical 3 over 2. Okay. On a calculator, square root of 3 over 2 is like 0.866. Okay, I'm not even sure if I ever showed that to you, but maybe just to convince you of that. Square root of 3 divided by 2. But if you can't see it that well, then you can do it on your calculator. 0.866, way more than half. So I go like this, right? Is this halfway across the circle, or is this halfway across the circle? This looks like it's halfway, right? It's halfway between the origin and this point right over here, 1, 0, as an x coordinate. How about the y coordinate? It looks way more than half, which means it's the other number. The other number is radical 3 over 2, like that, except that I'm in quadrant number 4. Okay. Okay, and 11 was asked for, which means we're done with all of these problems, I guess. So cosine of t is equal to -4/5, and t is between pi and 3 pi over 2. Cosine of t is -4/5. T is between pi and 3 pi over 2. Okay. Pi 3 pi over 2. So which quadrant are we in? Quadrant 3. So if I do all students take calculus, the only trig function among the 3 big ones, sine, cosine, and tangent, right? The only one that's positive is tangent. Cosine is negative. Sine is also negative. Okay, so I'll keep that in mind. So when I do my calculations, I know that the sine, the SIGN, sine of the SINE is negative. Okay, so sine squared t plus cosine squared t equals 1. Sometimes you see the sine squared first, sometimes you see the cosine squared first. It's the same thing. So if they put the cosine squared first, that's all right. Okay, sine squared t plus negative 4/5 squared equals 1. Negative 4/5 squared is 16 over 25. Sine squared of t plus 16 over 25 equals 1. Subtract 16 over 25. 1 minus 16 over 25 is 9 over 25. Square root, square root. This time I want the negative. So the sine of t is negative 3/5. Okay, and I don't think I have to do the rest, right? Once you have this, you got the rest, right? Tangent is sine divided by cosine. Well, this is different because I have 2 negatives. Okay, I'll give you the tangent, but I'm not going to give you the reciprocals. The reciprocals are very easy, right? So let me show you this again. So tangent is sine over cosine, negative 3/5 divided by negative 4/5. Okay, and based on what we said earlier, right? The answer is positive, negative divided by negative. And I can just lose the 5s, so 3/4. And by the way, that does match what we thought, that the tangent in the third quadrant is positive. But the sine is negative, SINE is negative, where to go? And the cosine is negative. So if I divide them, I get a positive, as it should be. Okay. All right, so that's that one. Okay, check back the chat. Okay, problem 11. All right, got that. I think I'm caught up. Yeah, if somebody just joined, send me an email, please. And I'll take care of that. Okay, I think I'm caught up with the chat. Let me double check. Yeah, I'm good. All right, so any other questions? You can unmute yourselves or send it in the chat. And if not, we're done. So I'll wait a few seconds. Okay, so again, tomorrow I'll get started with some graphs, give you the graphs of the tangent, cotangent, secant, cosecant, but I probably won't do a whole lot of problems or maybe no problems. So I'm going to give you enough time to do the quiz. So tomorrow's quiz, again, I'll give you a graph and you come up with either a sine or a cosine function based on the graph that I give you. Okay, and again, you don't have to finish it in class. You get the whole weekend, you know, the whole spiel. I'll set you up into your breakout rooms and then it's due, what, 9 o'clock on, or 9:10 on Monday morning as usual. Okay. All right. Anybody else, please? All right. We're done, folks. Okay. So have a good day and we'll see you all tomorrow. Thanks. Bye.